Hey, my name is John Geraghty, and I am the program chair for the master's program in mechanical and manufacturing engineering. Um, so, um, there's many reasons why people want to take on a master's in mechanical and manufacturing engineering. There's a lot of uh, new pressing issues that are demanding engineers' attention to solve and find solutions for personal reasons for doing it, things like career opportunities, change your job, change your direction of your career, be able to contribute and build new stuff and do new activities in your career. So there's lots of personal reasons as to why people wish to choose to do a master's in mechanical manufacturing engineering. And obviously, qualified engineering graduates are in extreme demand at the moment. So, in terms of the program chair role, that's me on the right-hand side there of the screen in the blue t-shirts. You can contact me at john.geraghty@dcu.ie. I'm the program chairperson. Tomas is the deputy chairperson, and his email is also there on the screen. And if you can't get me, Tomas is experienced ex-chairperson of this program, so he knows the program inside out, and he can answer any questions that you might have. The master's program has a structure that allows for different types of graduates to enter the program and to ultimately hope graduate at a point in time with a master's degree. The primary entry is for people who have, and you can see it in the green up there, people who have a degree in mechanical and or manufacturing engineering and have a level 8 award with a H22, so a second class honors degree with a lower level achievement. Those people can progress through directly on the master's program by selecting 8 modules over 1 year period worth 60 credits and doing a 30 credit project and accumulating 90 credits and graduating with a master's degree, and have, as you'll see later, an option to graduate with a major in particular areas as well. If you've not achieved the minimum entry criteria of a H22 and have a H3 award, you can enter the program by choosing what we call our master's qualifier route. That's on the left there of the screen. This requires you to take 4 modules over the course of a year from the master's program. These are at level 8 or 9, and it's summed to a total of 30 credits. Successful completion of the master's qualifier will allow you to transfer to the master's program in your second year. The 4 modules that you will have completed at the master's qualifier in the first year will carry forward to the master's program. So they are modules from the master's program, and you'll be able to carry your results. So you will have 4 modules completed of the 8 that you're required to complete for the master's program, and you will only need to complete in your second year 4 more modules and a project in order to graduate with the master's degree. Failure to successfully complete the master's qualifier does not necessarily mean that you can't graduate with an award. If you've accumulated 30 credits at level 9, so if all 4 modules on the master's qualifier were level 9, you've passed them, you cannot at that point to exit with a graduate certificate. There's no requirement for you to transfer to the master's program. The master's qualifier itself does not offer an award certificate. So, for example, if you only pass 3 of the 4 modules on the master's qualifier, then there's no award, there's no certificate or diploma awarded to in that scenario. A third option that we have for entry to the program is identified as the access route or the access course. And this program is primarily designed for people with a science or technology background, level 8 primary degree at H22 award, but don't necessarily have a degree in mechanical or manufacturing engineering disciplines. The Access program offers 6 modules at level 8, which is usually what undergraduate program modules are. And these are 30 credits that are accumulated over a 1-year period. So you will study 3 modules in your first semester and 3 in your second semester. Successful completion of the Access program allows you to transfer or enter the master's program. The modules that you take on the Access course are not transferable to the master's program, so you still need to complete 8 modules plus a project in the master's program, having completed the Access course. The Access course has a requirement that since all the modules are at level 8, you must achieve a minimum mark of 50% in each module in order to pass the module and gain entry to the master's program. We also see that on the qualifier route, the minimum requirements for passing modules in order to continue to the master's program is to achieve a 50% minimum mark in any modules that you take that are level 8 modules, and 40% is the minimum mark if the module is deemed to be a level 9 module. So there are some alternative exit routes there as well as leaving with the master's degree. If you accumulate 60 credits from taught modules, you can opt to leave with a graduate diploma. Essentially, that would mean not completing the project and exiting with a graduate diploma on the basis that all of the modules you've taken are level 9 modules. If you have accumulated 30 credits at level 9, you opt to leave with a graduate certificate. A graduate certificate is considered to be a level 9 minor award, whereas a graduate diploma and master's degree are major awards at level 9. So the Access program, just very briefly, is for students who do not have a primary degree in mechanical and manufacturing engineering. It consists of 30 credits being accumulated over a 1-year period from 6 level 8 modules. Level 8 modules typically are or in this course are 5 credit modules, and they must be passed with 50% minimum, and there's no carryover to the master's program. So typically we consider Access program to be a part-time mode in that you're only taking 15 credits per semester. Typically, full-time registration is for 30 credits per semester. These are the modules that are offered on the master's program. So you can see that there are 2 fundamental engineering mathematics modules. There's a manufacturing process module, mechanics and machines. There are 2 modules, and thermofluid mechanics. So these are foundation modules basically for engineering. And for those who don't have an engineering background, specifically mechanical and manufacturing engineering roles, it is required that you're able to demonstrate that you have acquired the fundamental knowledge and skills that these modules teach before we're allowed to enter the master's program. The qualifier itself, as already discussed, is for mechanical and manufacturing engineering students who have a level 8 degree, but have not acquired the H22 minimum qualification. This requires you to take 30 credits over a 1-year period, so 15 credits per semester typically. You have to have, from that 30 credits, the modules are 7.5 credits usually, so you're taking 4 modules, and 2 of them can be at level 8, other 2 are at level 9. You must pass any level 8 modules with 50%, and credits are carried over to the MEng. In the MEng, then, if you've successfully transferred to it, you will only have to complete a further 4 modules plus the project to graduate. Typically, if you take the master's qualifier route to the MEng, you will complete the MEng over a 2-year period. In the first year, you will complete taught modules in semester 1 and 2, typically 2 modules in each semester. And in your second year, you will complete 2 modules per semester as well, and also a project. And the project is shown there starting in semester 1, but actually now starts in semester 2 and runs over the summer period. It is a requirement for the master's qualifier that you must register for the module research practice and methodology as one of your modules. This module is now offered in the second semester, and you select other modules then from our list. The master's itself, which is the main route through the program, is optional to be taken in full-time study mode or part-time mode. In full-time mode, you will take 30 credits per semester. Semester 1 and 2 be 4 modules per semester. And in semester 2, you will also start your research project, which is worth 30 credits, and you will complete that typically around end of July, start of August. So it'll be during the summer period that you make the submission on that. The other option is to take it in part-time mode. In a part-time mode, you effectively split the module load across 4 semesters rather than 2 semesters, taking 2 modules per semester over a 2-year period. You also delay the start of the project until semester 2 of your second year, but you still have to complete that module. There's also an option for a January intake. Most people are probably looking at this, considering September as their start date, but there's also an option for a January intake. In the January intake, your first semester is actually semester 2 of the current year, and your second semester will be in the second academic year, so from September. You will, however, have to start your project in your first year in order to complete the master successfully if you enter in January. So we have a list of modules that are available in each semester. There's quite a range of these modules. 2 of the modules in semester 1 are level 8 modules. All other modules on the program are level 9 modules. The 2 level 8 modules are prerequisites for 2 modules on the program. So if you have studied this material before in another module, you don't have to register for these modules. Okay, but if you have an intention to register for the advanced FEA module in semester 2, or the computational thermofluid dynamics module, you must take these prerequisites or demonstrate that you've already taken a similar module in your undergraduate degree and achieved a pass mark in that module. So the majors of the master's program are simulation-driven design, advanced manufacturing, sustainable systems and energy, and biomedical engineering. There's an asterisk there on biomedical engineering because this is not available for January intake, because one of the modules on that major, which is designed for medical innovation, is a year-long module. That module is already running for a semester by the time people will come in January. So you can't register for the biomedical major if you come in January. So the major will depend on the stream of modules that you have selected. So it's based on completing at least 4 modules in one of these topics. So you have the option of not taking a major and just taking the master's as a general master's degree in mechanical and manufacturing engineering. In that route, 4 modules that you must register for are research practice and methodology, which is now delivered in semester 2, and the project in mechanical and manufacturing engineering, MEC 1063, which is worth 30 credits and starts in semester 2 and is completed over the summer period. For the major in simulation-driven design, your core modules are listed here. So in addition to research practice and methodology and the project module, there are 4 other modules: manufacturing system simulation, turbomachinery, advanced FEA, and computational thermofluid dynamics that you must register for if you wish to take this major. You then have to select 3 further modules at 7.5 credit from the list of modules. Anyone opting for advanced manufacturing major also has to take research practice and methodology and a project. There are 3 core modules then, which is engineering management and economic analysis, manufacturing system simulation, and manufacturing process analysis and tool design. And you're required to select another 4 modules at 7.5 credits from our optional list. The major in sustainable systems and energy has core modules listed there as energy systems decarbonization, energy auditing and energy management, advanced sustainable energy systems, whole life cycle analysis, and global sustainable development challenges. Of those 5 modules, in order to take the major, you must have completed 4 of those 5 successfully, and 3 more 7.5 credit modules. The major in biomedical engineering requires, again, research practice and methodology and a project module. And then there are 4 modules there: designed for medical innovation, advanced tissue engineering, regenerative medicine, advanced FEA, and computational thermofluid dynamics that you must register for and complete successfully in order to acquire this major, along with 3 other 7.5 credit modules from our list of modules. As you can see from this as indicative timetables, the timetable is quite full in both semesters for anybody who opts to take this in full-time mode. Generally speaking, a lot of the modules are in blocks. This enables people who want to take it part-time mode to take 2 modules and be able to complete those 2 modules on maybe a single or over 2 days in a given week. In terms of the exit awards, as we've already seen, the normal exit route is a master's in mechanical engineering with possible majors. You must have accumulated 90 credits successfully, of which 30 of those credits come from a project and 60 of those credits come from 8 7.5 credit modules. The alternative exits are graduate diploma, which requires 60 credits. All 60 credits are talk credits, and they must be from level 9 modules in order to successfully take a graduate diploma. The graduate certificate is offered to candidates who wish to exit after having successfully completed 30 talk credits from level 9 modules. So that would exclude those 2 modules that are prerequisites for FEA and computational fluid dynamics. If you have any questions, contact information is shown here on the screen. For general inquiries, you can contact postgraduate admissions at dcu.ie. For program deadlines, you can email registry@dcu.ie. If you have any questions with regards to fees, please contact the fees office at fees.dcu.ie. And to apply for the program, there's a link there, www.dcu.ie, your guide to student application portal, to give you information about how to make your application successfully. Now, thank you very much for listening. I am going to hand you over now to two of our former graduates on the program, Naveen and Abhijit, who are going to maybe give you a little bit of advice about things that they found good on the program, things that maybe they wish they did a little bit differently, and so on. So they're just going to talk to you about their experiences of the program. Okay. So, Naveen, would you like to jump in?
Yeah, no problem at all. And thanks, John, for having me here. So, just a very brief introduction about myself. I actually came to Ireland in 2019. September 2019 was when I arrived, and I obviously. Looking back now, I think I was part of the one of the most unique cohorts in recent history because it was kind of when we started the program, everything was completely normal. We attended lectures the traditional way, worked with classmates in person, and experienced university life in the traditional way. And then a few months later, the world changed because that was when COVID-19 started, and our program transitioned almost entirely online. Lectures, assignments, project work, presentations, and even examinations moved to a virtual environment. And like many students around the world at the time, we had to kind of adopt very quickly to a completely different way of learning. But regardless, at the time, it was certainly rewarding because I believe that that experience taught me some valuable lessons that have stayed with me throughout my career. It taught me adaptability, self-discipline, time management, and the ability to work independently when circumstances were not really ideal at the time. Uh, but obviously that things have changed now, and obviously DCU is kind of back to its traditional way of delivering the program. So just speaking about the program itself, one of the aspects of the MEng program that I found the most valuable was the emphasis on assignments, project work, and independent research. These weren't simply academic exercises. They taught me how to investigate technical problems, review and evaluate information, and analyze data and communicate findings in a structured and professional way. Uh, Especially the project in particular, it gave me the opportunity to approach a problem, methodically and develop solutions based on evidence and analysis. Another thing I probably didn't realize fully at the time was how important communication was, communication skills, through technical reports, presentations, group work, and project discussions. Um, I became much more confident in communicating complex and technical information to different audiences, Uh, so just to give you a brief background, that was just a brief background about myself. And today I'm actually working as a technical engineer in a company called SE Systems, which is based in County Cork, and I'm working in the solar industry. Interestingly, my current career path isn't directly related to every subject I studied during my master's program. However, I don't see that as a drawback. In fact, I think it highlights one of the greatest strengths of engineering education. Because the way I see it, engineering careers rarely kind of follow a straight line. The technologies, industries, and opportunities around us are constantly evolving. What the MEng program gave me wasn't just technical knowledge. It taught me how to learn, how to think critically, and how to approach problems in a systematic basis, and the analytical thinking, problem solving approach, and engineering methodology I developed during the program. Those are things that I kind of use to this very day. So uh, it was certainly challenging, but it was certainly rewarding as well. Uh, and I guess that's kind of it, like, and my advice for anyone considering to accept the offer from DCU would be to make the most out of every opportunity available to you, engage with your lecturers, participate in projects, develop your communication skills, build your network, and don't be afraid to challenge yourself. The knowledge you gain is important, but equally important are the transferable skills that will support you throughout the career. You may not know exactly where your career will take you in 5 or 10 years' time, and that's perfectly okay. Uh, because the purpose of a master's degree isn't only to prepare you for a specific job, it's also kind of to equip you with the tool sets and confidence to adapt and succeed wherever you end up. Um, that's kind of it from my side, yeah.
Thank you very much, Naveen. It's very interesting to hear you focus in on some of the skills that you're kind of picking up along the way, and not just necessarily what's in the core modules and what's examinable
Yeah.
material, but the skill sets you're developing in order to be able to communicate and conduct research and so on. So that's interesting. Um, Abhijit, would you like to
Yeah,
offer some
thanks, John.
advice?
Thanks, John. First of all, I would like to thank the mechanical and manufacturing engineering team to inviting me. Uh, and it's a wonderful day, sunny day outside in here in Ireland, everywhere. So my name is Abhijit Cholkar, and I'm an international alumni of MEng Mechanical and Manufacturing Engineering. So I originally came to DCU in September 2019. Naveen was my colleague in the same course, and basically, my aim was to gain advanced engineering knowledge, experiencing a new academic environment. So it was a totally new academic environment for me coming from India. So uh, basically, altogether, I was in a new country, new environment, new people, and but as Naveen said before, it was more smooth because all the lecturers and everyone was very supportive to us, and I was living on campus in DCU as well. So it was more like DCU was like a second home to me, or it's like a second home to me because I still have my friends living in DCU. So I chose MEng Mechanical and Manufacturing Engineering because it offered combination of like advanced engineering principles and manufacturing technologies, as well as computational methods and research as well. So all these things combined was only in DCU, and that was very new because, for example, I looked in different universities. I was browsing through different universities, and there is no this type of program elsewhere because you don't get all together, everything together. So that's really good, and it is also accredited by the Engineers Ireland, so which makes it more good and like professional at a professional standard. So uh, that was one of my motivation to apply to this course. And basically after in this course, basically one of the key uh, module which I felt interesting was product design development and value analysis, because I'm mostly into product designing development, and additionally there was an economic side to it about value analysis. So that made it a different type of module, and that was very interesting. Secondly, the research practice and methodology helped me to try to it was like a stepping stone for me. All these methodologies I used in my PhD. So I did my PhD from DCU as well after my masters, and it was like a stepping stone for me. So this module, especially research practice and methodology, gave me knowledge about design of experiments, which I used in my PhD. And they were really that type of data analysis knowledge and research methodologies to follow was very much important for during my PhD. Also, I gained a lot of communication skills by talking to different colleagues, talking with different students, uh, professors, etc. During the course, which developed me and gave me the confidence to speak with at different conferences as well. So it was kind of very it was a starting point for me in my masters, because from bachelor's that was more theoretical knowledge, whereas here I was implementing that knowledge along with the soft skills as well. So also in this course there was a big uh, emphasis on advanced finite element analysis methodology. So in that, basically, uh, for any engineering problems, uh, finite element analysis makes it very quicker to solve, so that you don't need to do big experiments. Say for example, right now I am working in additive manufacturing, and finite element analysis can be used to simulate additive manufacturing before we prepare the parts. So we know what process parameters to apply. So that's like it's like a chain. So uh, that was it gave me this course gave me a deeper knowledge of that, and even CFD. So total, like, it's like a combination of all engineering aspects in this course. So that made me it became my PhD was easier. It became easier because of all these modules covered. So whenever I used to go to my supervisor, Dermot Brabazon, who is also in mechanical engineering, he used to ask me, like, have you finished this module? And it was already done during my master's time. So during my PhD, I didn't have to take more modules. So it was a really great foundation for a researcher. And now I'm working as a postdoctoral researcher at SEAM Research Center in SETU in Waterford, in Ireland. And it so initially it because of the masters, it gave me a really good uh, uh, like a 1 year period, which was challenging. At the same time, it was very enjoyable as well. So I got new friends. Of course, we still talk to each other, connect with each other. We have already been connected, and also uh, uh, basically I was also a part of badminton society at DCU. So I used to play badminton and used to connect with other people as well. And as I said, like, DCU is like a second home to me. So I still am in connection with other professors as well, like Dermot Brabazon, David Kinnan as well. So and for international students, I would strongly recommend participating in societies in the university, uh, because they give you balance between academic life and personal development. So that helps you as a person as well. And uh, so basically, uh, I would like to give you an advice to the students who are planning to join DCU, especially the international students. First, be open to learning and adapting. Secondly, make make the use of the facilities, like for example, research opportunities or expertise available at DCU. Even you have your professors who can help you during during their time. You can book their time and ask them as long the any questions you have. Even not even one question is a bad question. So basically, all the professors uh, may like, if they know, they can answer your questions very well, because they are experts in the field. Then build relationship with your teammates, with other students, even from other faculties. So because DCU is a huge university. It has like 17,000 people. So you have more opportunities there. And finally, um, don't forget to enjoy the journey. So that is more important from the aspect. So that's from my side. Yeah.
Thank you very much, Abhijit. Sorry, I'm trying to find the unmute button there. Again, very interesting to hear about your journey through the master's program here in DCU, and again to see you comment on things other than just the raw academic skill sets that you're developing, but kind of the soft skills that you're using every day now in your new roles, and the relationships that you built both personally and professionally through your time here in DCU, and for you to focus on that, encourage people to take every opportunity that they can when they come here to join societies, clubs, and to get involved in any activities that might be going on in labs and lectures. And as I said, most lecturers are approachable. Their time can be booked by students to ask questions and so on. So it's not just having to attend the lectures and get all your answers there. Okay. So thanks again, Naveen and Abhijit, for joining us today. It's very interesting to hear your perspective on life here in DCU.
No, thanks for inviting us, John.
Thanks, John. Yeah.
Okay. Well, maybe we'll catch you again another year for this. Thank you very
Certainly,
much.
that's
And
no
stay in
problem.
touch with us here in
Definitely.
DCU.
Will
We
do.
like to